Right, greetings, fellow grade 10s. Look, it's Mr. Shachar again. Now we are back again with back to basics. Now let's look. Now we are going to be attempting today a paper of November 2018, and we are still looking at our 2D shapes, right? Now let's look at this one. Now they're saying and the diagram below. You are having ABC, and also ACD, and also ADE, which are your right angled triangle. So now what is it that you are given? You are given that your BAE is 90 degrees, your BAC is 30, BC is 20 units, and your AD is 60, right? Now let's look at the first one. Now the first question asks us to do it. Now they want us to calculate what is going to be the length of AC, right? Which means this particular length, right? This length of AC. So now what is it that we can do in order for us to calculate for this length? Let's start here. Now remember that we are having the three trigonometric ratios, which is your sine of theta, your cos of theta, and your tan of theta. Now let's see. So the first thing that we are required to do here is to identify which trigonometric ratio are we going to use in this particular problem. Now, and how do we identify which trigonometric ratio are we going to use? Now we check in terms of what is it that we are given. Now, so if you can check, you are given this angle here, right? So we are given 30 degrees, and now you are given a side that is opposite to that 30 degrees, and you are also given the side that is your hypotenuse side. So you are given a side that is an opposite, and you're given a side that is your hypotenuse. So which means which trigonometric ratio now concurs with opposite and hypotenuse? Remember, this is so which O over H, right? And this one is K, which is adjacent over hypotenuse, and this is opposite over adjacent, right? So which means the trigonometric ratio that concurs now with your your basically your opposite over hypotenuse, it's going to be your sine, right? So therefore now what is it that you're going to do? We are going to say, look, now 4.1.1, we are going to use sine. This is going to be sine. This is going to be sine now of what? Because this is 30 degrees, your angle of theta. So this is going to be sine of 30 degrees is going to be equal to the opposite side. Because remember, you must start with the opposite side here. And the side that is opposite, it's going to be 20 over now the side that is going to be now your hypotenuse side. It is the AC side that we are looking for. And now what is it that now we can do now from here? Then we can try and multiply in here and see what is it that we are going to do. Now look, so when you multiply, remember this is same as now over 1 here. You can make this to be over 1. And now you can cross multiply. So when you cross multiply, we are going to have AC sine of 30 degrees, which is equals to what? Which is going to be equals to 20, right? So what you did, basically, you multiply the 1 with the 20, the sine of 30 degrees with an AC. And now what else then now we are going to do? So then you're going to divide by the sine of 30 degrees this side, you divide by the sine of 30 degrees this side, right? So this one and these ones are going to cancel. So which means the value of your AC that you're going to get, you're going to get that your value of your AC in this case, it is going to be your 40, right? This is going to be your 40 units. So this is going to be now the value of your AC, right? Hopefully now this makes sense. So now let's look at now our 4.1.2 and see what is it that you are given. And please make sure that after that, now what is it that you are going to do now? You are going to come back in here and substitute back the value that you found here, so that now whenever you are looking for the next unknown, you know that you have at least maximum information. So we are saying this now, your AC, it is going to be 40 units. So you'll come back and substitute it back in here, right? Now let's see in terms of what else now can we have in here. Now, so this question now require us to calculate what is your angle C, A, and D. So basically, which means they are basically looking for this angle, because your angle CAD, it is going to be this angle, right? The C, it's A, it's D, right? So which means even if you can try and draw a line here, this is going to be here. your C. Can you see that? And then this is your AD. Can you see that? Let me just, you see? So basically it's that particular angle. Now, what is it now that we can do to find the angle in here? Now look, if I can take the same triangle, your triangle CAD, and draw it in here, can you see that this triangle is going to look something like this? Let me draw it for you here so that you can see. Now it is going to look at least almost something like this. So it is going to look like this is going to be your C here, this is going to be your D here, and this is going to be your A. So what I did is I just extracted this triangle and wrote it in here. Look, this here, it is the 40 that we found, which is this one, and this here, it is the 60 that we found, which is this one. Right now, what is it now what we can do to now calculate for this angle? Now, firstly, we are going to check what is it that we are given. Now we are given this side, right? You are given this side, your side AC, and your side AC, basically, it is adjacent in relation to the angle that you're given, right? Remember, adjacent side just means next to, right? So you have the adjacent side and you are having the hypotenuse side. So what is it that now we can do if you're having the adjacent side and the hypotenuse side? So now what you are then going to do, look, you are going to say now the trigonometric ratio that is associated with adjacent and the hypotenuse, surely you can see it's this one. It is your cos. So it's going to be your cos. Remember, your cos, it's car, which is adjacent over hypotenuse. And here, indeed, you are having the adjacent side and the hypotenuse side. So we'll come and say, look, this is going to be the cos of what? Of CAD. And what is going to be the cos of CAD now? You're going to say the adjacent side, it gives you 14. And your side, that is your hypotenuse, it gives you your 60. Isn't it so? And then now, which means now this, your cos of CAD, it is 40 over 60. Right? And then now, what is it then that you can do? Now you can then try and calculate what is going to be your angle CAD. Your angle CAD, it is going to what? It is going to be now your cos of what? Your cos of 40 out of 60, right? Or 40 over 60. And which means now what is going to be that particular angle that you're going to find in here when you press shift cos into bracket 40 out over 60, the answer that you're going to get is going to be 48,19 degrees. Right now, that is going to be the answer that you are going to find if you are going to plug this in that particular calculate now. And then which means this angle here is basically what it is, basically now 40,19 degrees, right? So this is going to be now the angle, so which is going to be that particular angle. Now let's look at the last one. Now the last question, which is your 4.1.3. Let's check what does this one require us to do. Now for your 4.1.3, what basically this question require us to do, it wants us to calculate what is going to be the length of DE. Let me just get another color. Now, it requires us to calculate what is going to be the length of DE. So it wants us to calculate what is going to be this length here. Now, let's see now in terms of what is it that we can do to calculate for this length. We are going to start here. Look, now already we have 60 here. Now, if I can try and plot this triangle here, let me try and plot it very nicely. If I can try and just take out this triangle and plot it in here so that you can see what is it that you are required to do here. Let's see. Look at this line doing what it requires to do, not what I want it to do. Now we are plotting in here. This is our triangle, you see. Now, what is it that now we are going to do now here? Look, so can you see that this is going to be your D, and this is going to be your E, and this is going to be your 90 degrees, and the one that is already given there, your A, it is what? It is 60. Now, what is it that we can do to find out this side here? Because they require us to calculate this side of DE. Now, if you can check now here, if you can check this angle here, the one that I'm highlighting here, can you see that this particular angle is going to be 90 degrees, right? So which means the first thing that we can do now, we can try and calculate what is going to be the angle in here. right? You see the one that I'm highlighting here? Yes, you're going to try and find out what is going to be the angle of this one. And if you're finding the angle of this one, basically, which means you are finding the angle of this one, which is your angle DAE, right? So what is it that you are going to do? You are going to say, look, now your angle DAE, your angle DAE is equals to, remember, you are already given that this is your 90 degrees because there is a block there. It is going to be 90 degrees. Look, if you are given that this is 30 and this is 40, 19 degrees, and this one, can you see that all of these angles must give you your 90 degrees, right? So this is going to be 40. Now subtract the 30 degrees that we've calculated, right, or that was given to you, plus the 48, 19 degrees, right? 19 degrees, which is the angle there. So now, which means your angle DAE, your angle DAE that you are going to find in here, it's going to be what? It is going to be given by, let's see, let's punch in our calculator. If we plug in our calculator, you're going to get 11,81 degrees, right? So which means this angle here, it is 11,81 degrees. Does this make sense, right? Now, this is 11,81 degrees. Now, then we can be in a position now to calculate what is going to be now your angle DE. Because look now, the related side, it is positive that you're looking for. And you are having the what? The side that is adjacent. Right? So now what is it that we are going to do then? Which means now, look, the trigonometric ratio that is associated with this now, it is tan. Let's leave this one here. It's tan, right? Which is what? Which is opposite over adjacent, which means we are going to use now tan. We are going to say, look, tan of 11,81 degrees, right? It is going to give us what? Now look, tan, it is opposite, and the opposite side, it is the DE side that you are looking for over your adjacent side, and the adjacent side, it is the 60 that we are given, which is going to be the 6th, which means now if you can try and cross multiply here, if you make this over 1, can you see that your angle DE, or rather your side DE, is going to be 60 tan of 1,81 degrees. Can you see that? And then now, which means now your side DE that you are going to find in here, it is going to be same as 11, or rather 12, not necessarily 11, but it's going to be 12, let's write it correctly. It's going to be 12, 55, or rather 55 units, right? And then this is going to be your side DE that you are required to calculate. So basically now, this is how we solve our 2D shapes.